Okay, so what we got here is we're going to start section 8.4, and it's the divergence and integral tests. I think we'll see how I feel here. I think I might just cover the divergence test here because I'm hoping some of you will email me some questions that I can make some videos of to answer because normally we would have time to go over some homework questions. And as far as the homework questions you should be asking would be at this point, 8.1 up through 8.3. You should be able to do all those homework questions now. So please email me. I will send an email reminding you of this, but if you do send me an email question, I don't have my textbook with me with where I'm at. So make sure to take a picture of the problem with your cell phone from the textbook and email me the picture so I can see what the problem is. Because if you just say problem 77 and 8.2, I'm going to have no idea what that is. All right, so let's go ahead and get started on section 8.4. So the divergence and integral tests here. So what we had said, remember, there are two items we like to know about series. And this, of course, would be the time where I would ask you guys in class to, tell me what are those two items. And so, I'll wait for you to communicate this telepathically to me. I'm joking, of course. But the two items we're interested in is whether the series converges and if it does converge, what does it converge to? Those are the two items. And remember, we said that the second one here is actually the harder question. And in the previous section, we answered both those questions with the geometric and telescoping series. We were able to determine not only whether they converged or diverged, but we were able to determine what they converged to, if they did converge. From here on out, for the rest of Chapter 8, we do not get to determine what it converges to. We only get to determine whether it converges or diverges. So these are solely tests for convergence / divergence. That's all they can be used for. Now, the first one here, the name kind of, I think, gives you a good indication of what it is here. And we'll get to the name of this test, and we'll get to this test just by examining a couple of series and see what's going on here. That's obviously going to be an issue for us. So let's look at a simple series that we even looked at. We'll look at another geometric series here. So we'll look at sum from k equals 0 to infinity of 1/2 to the k power. So we know this series converges. We know that this actually converges to 1 over 1 minus 1/2, which is equal to 2. We know that. But I'm going to go ahead and write out the terms here. Which would be 1 plus 1/2 plus 1/4 plus 1/8, so on and so on, right? Now, what we want to see here is that each additional term added gets smaller. And not only does it get smaller, they approach 0. Because if I were to keep going out here, so if I were to write this here, this sum, you'd have 1 plus 1/2 plus 1/4 going on, and then I'm doing a couple dots here, plus then you'd have like 1 over 128 plus 1 over 256 plus 1 over 512, keep going on. But these keep getting smaller. I keep adding something closer and closer to 0. So, well, that makes sense here, and we know that series converges. And now I say, well, why does that make sense? Well, let's look at a series that doesn't do that. And we looked at this the other day in class as well. And we're going to just look at another geometric series that we already know the answer to. And we'll just, instead of looking at 1/2 to the k, we'll look at 2 to the k. And this, of course, is going to equal 1 plus 2 plus 4 plus 8 plus 16, going on forever. And we mentioned this the other day in class. What's the key thing here, though? Each term we add gets bigger. Well, and so I'll just say, of course, this can't converge. So what we've just done by examining these two things here, and I'm going to emphasize, I'm going to write this in a very special way. For the series to have a chance at converging, we must have the limit as k goes to infinity of these terms, a sub k, equaling 0. In other words, what I am adding on has to get closer and closer to 0. Because if it doesn't get closer and closer to 0, even if it doesn't go to infinity, even if I do something like this, let's look at something silly here. Even if I were just look at 1 to the k power, because this would just be 1 plus 1 plus 1 plus 1 forever. The number's not getting bigger or smaller than I'm adding. I'm just always adding 1. But if I'm always adding 1, I'm still going to go off to infinity. So in order for us to even have a chance for a series to converge, we must have that these terms that we are adding get closer and closer to 0, which we did have that in this case here where my ratio was 1/2. We didn't have it where the ratio was 2, and clearly we don't have that as well where the ratio is 1. So what would be nice for us would be if that was the end of the story. Was just saying, oh, if that limit as k goes to infinity, if that goes to 0, we're done. Unfortunately, just having, and I'm going to emphasize this, just having the limit as k goes to infinity of a sub k equaling 0 is not enough to conclude the series converges. Well, some of you might be saying, well, why did I bother even writing it down if it's not enough? Well, because we can actually use this to create our first test. And so this is called the divergence test. And people use this test wrong all the time. I'm going to, before I even write down here, I'm going to put it in a different color, and I'm even going to write it in a thicker line here. Can only be used to say a series diverges. Never use to say a series converges. And in fact, if you say that a series converges by the divergence test, I will probably take off almost all the points in the problem. And to me, it's a pretty obvious one that you should know that you can't use the divergence test. The name tells you, divergence test. So what is it going to tell you? Divergence. It's called the divergence test. So it only tells us whether a series diverges. So the divergence test is given a series and I'm not putting the indexing down here because I'm just saying it. I don't care what the indexing is. It's just some series. So given a series a sub k, if the limit as k goes to infinity of a sub k does not equal 0, then the series diverges. That's it. So it's really not a huge test here. Let's look at a couple examples here of applying the divergence test. So we have a series from k equals 0 to infinity of 2k over k plus 1. So we're going to use the divergence test. And again, when we get more of these tests done here, we'll talk in class or on these videos about how do we know which test to apply in which case, because that can be the tricky part here, is to know which test to apply. Alright, so, excuse me there, I just belched a little bit. This is obviously a divergence test because that's all we've talked about. When we get the other tests going in this course here, you'll be able to discern why this would be a divergence test a little bit better. So we're just going to go ahead and look at the limit as k goes to infinity of 2k over k plus 1, because that's all we can do with the divergence test, is look as what this limit of these a sub k's go to. Now, just going back to Calc 1, beginning of the semester of Calc 1, remember that this is equivalent. You can just look at the lead terms of the numerator and denominator. So this would be limit as k goes to infinity of 2k over k, which is equivalent to the limit, or the kim, equivalent to the limit as k goes to infinity of 2, which of course is just simply 2. Okay, well, the limit as k goes to infinity of a sub k does not equal 0, so we can conclude that the series diverges. And just to kind of see what's going on here again a little bit more in detail, let's look at some of these terms again. If we were to write this series out here, so we know it diverges because basically that thing doesn't go to 0. So, but let's look at some of the terms again. So if I plug in 0, you'd have 0 plus 1 would be 2 over 2 plus 2 would be 4 over 3 plus arithmetic is failing me now. 3 would be, need you guys here, 6 over 4 plus 8 over 5 plus 10 over 6, going on forever. But what you can see here is, yeah, the number keeps getting bigger, but actually if you look at what these decimals are here, this would be 0 plus 1 plus 1.3 repeating plus 1.5 plus, I need to pull out my calculator here, 1.6 plus 1.67, and yeah, we keep getting bigger, but what we're going to do is, if I keep going all the way down here, much further out, I'll be adding something like 1.99. That's what we're saying, is when this limit's equal to 2, is eventually when you get all the way out here in this series, we're essentially going to just still be adding 2 all the time. And if I keep adding essentially 2 all the time, I know I'm going to diverge. I'm going to go off to infinity. So that's really all we can do with the divergence test. I want to do one more example here. And the other example I want to do here is the series from k equals 0 to, actually I need to not do 0 because of the series I want to do, 1 to infinity of 1 over k. So if we look at here, limit as k goes to infinity of 1 over k, we get 0. So the question is, what do we write down here? Well, basically, at this point, we can't say anything. Now, what do I mean by we can't say anything? Well, the only test we have at this point is the divergence test. And it only tells me if something diverges. And it's only if this limit is not equal to 0, then I can claim that it's a divergent series, like we did in the previous example. But basically, if we try to apply divergence test, the result is inconclusive, because we don't know what happens at this point when this occurs. And now, on a quiz or an exam, you'll never get a series that the result is inconclusive. There will always be a way for you to determine whether it converges or diverges, but we have to kind of get into that in more detail. Now, just as a side note, and we'll talk about this in the next, well actually, I think I'm only going to have these 2 videos because I'm hoping that some people will email me some questions on the homework. If not, then we would have had a short class. But we will learn in the next class period, or videos, depending on what it is that we need to do, that this actually does diverge. So even though these terms, eventually what you're adding on goes to 0, this actually goes off to infinity. This summation goes to infinity. And we will be able to see that once we learn the integral test. So this is going to use the integral test in order to determine that. But that is something that we will talk about either on Friday or in class or on another set of videos. Please check your email in case something, if you don't get an email from me, we will be having regularly scheduled class on Friday.